Lesson 661, Q4, Identifying Perfect Square Trinomials. In this problem, we have been asked to identify if the given polynomial is a perfect square trinomial or not. At first glance, we can see that it is a trinomial, but to classify it as a perfect square trinomial, we will have to carefully examine each term, and especially the middle term that is negative. Step 1 is to begin by looking at the first term to determine if the term itself is a perfect square. In other words, we need to see if the first term has a pair of factors that are equal. For 64z squared, the factors of 8z times 8z will yield 64z squared, and the factors are equal to each other. This means that the first term of our trinomial is a perfect square. We will label the factor of 8z as a. Now we shift our focus to the last term of our trinomial. Is it a perfect square? Just as before, we need to find factors of 1 that will be equal to each other. For this constant term, the factors of 1 and 1 multiply to be 1 and are equal to each other. But this is where we need to take into account the fact that the middle term is negative. Notice that -1 times -1 also multiply to be 1, and they are equal to each other. These are actually the factors we need to use because the negative signs they carry will account for the sign of the middle term. So the third term is a perfect square too, and we can label this factor of -1 as b. Now that we know both the first and last terms are perfect squares, we turn our attention to the middle term. Recall that we labeled 8z as a and -1 as b. Since the middle term of a perfect trinomial equals 2 times a times b, we need to substitute our values into the formula to see if it works. After substituting the values and simplifying the expression, we find it equals -16z, and this is our middle term. So the middle term fits the 2 times a times b pattern. Since our trinomial met all 3 criteria of being a perfect square, then it is a perfect square trinomial. This means it can be factored into a pair of equal binomials. In this problem, the binomials would be 8z minus 1 and 8z minus 1, or the quantity squared of 8z minus 1. Using algebra tiles as before, we see that the polynomial 64x squared minus 16x plus 1 creates a perfectly square area with dimensions that represent our factors of 8x minus 1 along the length of each edge. Again, if a polynomial is a perfect square trinomial, then the algebra tiles representing it can be arranged into a perfect square. Understanding and remembering the algebraic pattern for a perfect square trinomial will allow us to factor these types of polynomials quickly. While we have seen in this example that the sign of the middle term can be either negative or positive, in order to be perfect squares, the first and last terms must both be positive. So, to identify a perfect square trinomial, remember the 3 steps. Step 1. Check if the first term is a perfect square. Step 2. Check if the last term is a perfect square. Step 3. Check if the middle term fits the 2 times a times b pattern. If a polynomial meets all 3 of the criteria, then it is a perfect square trinomial, and it can be factored using one of these patterns.